So good evening. We are pleased to have with us tonight one of our own Montgomery Amateur Radio Club members, David W2LNX, who will talk to us about getting started with Winlink on HF. This is an important topic because Winlink is widely used in the emergency communications, especially on HF. And it isn't just for sending to other amateur radio operators. Winlink integrates with regular email servers to bridge the gap when regular email systems need a little help. So thanks, David, for taking time to do a presentation on this most important topic. And now it's over to you.
2 months ago, I did getting started with Winlink on VHF, and now we're doing HF. So I have to thank, up front, I have to thank Jim for setting up a Winlink, HF Winlink gateway at a convenient location, which really helps with this presentation because I wanted to get a good recording of a Winlink session. So thank you for that. That's WB3KAS email gateway on 40 and 80 meters, and I think 30 meters too, if I recall correctly. So here's an overview of the presentation. And there is actually a logic to the structure of how the software all relates together. So this is essentially the order of my presentation. So setting up an audio device. And once you have audio working, then you set up VARA-HF, which is the software modem. And we'll touch upon computer radio control. But as I will explain later, it's not absolutely necessary just to get started. So this is actually a getting started presentation. This is the presentation I wish I had 2.5 years ago. So if you can't find one, you have to write it yourself. And I'm going to use, setting up Winlink, I'm going to use an IC, this is about the 20-year-old radio, a turn of the century, an ICOM 706 Mark II-G that I borrowed from Tom, using a SignaLink USP. And the reason is, old radios are good radios. On the air, all radios sound alike. Yes, the new radios have DSP, SDR, built-in sound cards, built-in rig control, all that built-in tuners, don't forget that. And they have very capable power amplifiers, but that's really not necessary to establish Winlink communications. So we're blessed with something called NVIS for local HF. And I'll talk about that. And I did a video recording of a Winlink session on HF. And I didn't want to tempt the demo demons to do a live demo. Anyway, so the objective for you, your objective is to set up a basic working Winlink station to exchange messages with WB3KS and W1AW. They have big ears. It's a great station, as you can imagine. W1AW, the best antennas, the best of everything up there. So, American Radio Relay League, rather. So this is a conceptual model that you should have in your head, how this fits together. So on top of what the user uses is a digital modes program. In this case, we're using Winlink. But Winlink needs to talk to a so-called TNC. This is a term from, oh my goodness, the last century, last millennium. Terminal node controller, and it was a piece of hardware with a cable. And what comes out of that was audio that got plugged into the radio. Well, now we have very capable software modems. And we'll look at VARA-HF. Now, the software, the modem, in this case, we're using the SignaLink, but right off I have to tell you, whether you're using an external sound device, such as a SignaLink, or the one internal to the computer, excuse me, to the radio, it's, as far as Windows is concerned, it's the same model. Of course, devices need a driver to actually talk to the hardware, the actual audio interface. In this case, as in our example, the US, I have to get this right, SignaLink USB. And last but not least, the transceiver. Now I have to tell you, as an aside, I've actually taken two computers and aimed them at literally two laptop computers, turned them to face each other, and I did VARA sessions peer-to-peer between the two computers using just the audio. And it works. And of course, you jump up and down, you make noise, you clap your hands to see what VARA does with that. Anyway, now, on the right-hand side, essentially the same thing. Digital Modes program talks to a driver that talks to a serial interface that controls the transceiver, and that's used for RIC control, meaning frequency control, PTT, modes, essentially what matters. So transceivers ultimately are audio devices. Their job is to transport audio from one point to another point, and it's the audio device that's the interface between the radio and the modem software. But they're audio devices, and paradoxically, because it's digital, you need to get very faithful audio, as faithful as possible from one point to another. With human speech, with single sideband, you're off by a couple of hertz, or there's fading, or there's a static crash. The human brain, human mind can figure that out. But with software, you want to get the best audio across so that the software can make an correct intelligent decision, what's a 0, what's a 1. So the least distortion desired. So one of the things I learned, certainly for the lower bands, 40 meters and 80 meters, is to turn down the RF gain so that the background noise barely moves the S meter. So that when you tune into a signal, it'll pop out from that. Now, some transceivers can turn off automatic gain control. That's back from the AM days, where you have either a very weak signal or a very strong signal, and you know, and folks would be wearing headphones and their poor ears get burnt out. So we have automatic gain control, but that's for human beings. And for modems, that's not really necessary. Not all radios you can turn off the automatic gain control. So what I do is I use automatic gain control fast, so it recovers very quickly. And on transmit, you want to watch the ALC. More about that later. And we want to let the software do all the work. Turn off all the filters, open it up as wide as possible, and let the software, particularly the VARA HF modem, do the job. Now, audio devices are often called an external USB sound card. That's back from the 20th century when they had cards inside of PCs, venerable ISA sockets on the motherboard. So, as I said before, Windows settings are generally the same for whether it's internal or external devices. Now, I like the SignaLink USB audio interface. It's been around, wow, since last century. And it's a great device to get started with because it has a built-in Vox. And you can set Windows levels, audio levels, to a reasonable spot, and then you can tweak it. You can fine-tune it with the TX and RX control. And I put down here the delay is minimum, but I usually turn it up just a little bit so the CW identification doesn't clatter it that badly. But the best part is that the SignaLink has audio isolation. And I've demonstrated to myself and others that when you have a direct connection between the computer and the radio, you can introduce a ground loop noise and you can actually hear it. There are USB isolators, but they have their own issues. So I like this device. And it's plug and play. You get a cable for the radio. And all these links, which are underlined and in blue, are hot links. So those are clickable. Oh, by the way, this presentation is available on the MARC website. Just navigate on the left, and you look under education, testing, and classes. You click on that, and you'll see a link for training, and then you'll see this presentation. And later on, you'll see a photo of what's inside the SignaLink, but they also they can sell you a standard header module that you plug in that is a companion to the cable. And I found that these settings are generally pretty much the same for most HF radios. I can't say all because I haven't tested every single one ever made. So this is what it looks like. And again, this is a hot link if you want to buy one. And they have the device is standard, but with that, if you buy it, you can select the cable and the header module that's the companion to your radio. This is what it looks like inside. Now, some years ago, the original ones, I should back up, I should say that the original ones had crude audio transformers, and you could, when you look inside, they're red. They have and they actually look like a little transformer. And I don't know if you can see the mouse, but on the bottom there are two little blocks. Those are Bourne's audio isolation transformers, and I've actually tested it by sweeping an audio spectrum through it using Audacity, and it's very wide, and it's quite linear, within a decibel. So it's a happy improvement, because when you have digital modes and which are quite wide, you really want to get the linearity across the widest bandwidth that's possible. So it's a win for Tigertronics. So this is important. So I'm not going to rant, but I will make a comment about field day. It's quite annoying to hear the Windows beeps and the boops in the middle of people's FTA transmissions. So the first thing you should do is turn off all Windows sounds for your computer, so that if you forget the next steps, selecting the default audio device, which should be your speakers, not your SignaLink, and you got to select the properties. So you really want to have the maximum audio output to the SignaLink, so that to drive the PTT. And we don't need any enhancements. You want to get the highest digital that is sampling rate, which is 48,000 hertz. And we don't need to have simulated stereo in our head, so disable that. And same thing with the recording device. Now, it's a good idea to rename the devices. So, because after all, if you have several audio codecs plugged in, which is which? So you just label them. And that's something L, K, and 3U pointed out to me. Now, if the radios, like for example, the IC7300 or the FT991A has a built-in audio device, well, a good name for that audio device would be the name of the radio. So I've done that. And this is the initial input level, which seems to work. Same thing, highest quality audio. Now, the modem. So we've moved down from 2 levels. We started out with the software. Well, actually, I haven't gotten to that yet. Actually, I'm working my way up. I'm starting with the transceiver, the physical audio device, and then of course Winlink provides a built-in driver for audio codec, quite standard. So drivers are not needed to be installed for the SignaLink. And now we're moving on to the next level up, which is the modem. And this fellow, a Spanish fellow, he's a very, very talented electrical engineer. And he's been working with audio RF modems for, I would say, 20 years by now. And he developed something which is quite amazing. And you'll see a screenshot and you'll be amazed. So this is where you can download the software. He wants a couple dollars, $69. And when you first use it, it pops up with a little web page, but that web page can be found. And if you're serious, you're going to go full speed, then it's worth the $69. But let me tell you, he's very generous with the speeds in the free mode. I've tested it on VHF. The free version of VHF, and same thing with HF, gives you a reasonable speed. On VHF, it's actually like 3 times faster than AX25 packet, 1200, that is 1200 BPS packet. So it's quite usable. Now, if you're going to transfer large files, then it behooves you to pay the couple dollars so you can go a little faster. So this is what it looks like when you first get it. And this over here is the bandwidth that I selected to use. Now we're talking HF. So it's a good idea as a default to always stay within a 500 Hertz bandwidth. That's what you're using. Voice is the sideband 2400. CW is 50 Hertz, just for comparison's sake. There's also 2300 Hertz bandwidth for VARA, but HF is pretty crowded. So this is where you put in your registration key. But what I really want to point out is accept 500 Hertz connections. So this is on the receive side. So the modem has to be able to accept that. And I'll show you how to set it on the transmit side. That's a Winlink setting. Well, this is something you have to check. Make sure you select the right device, which is the SignaLink. Now, when you transmit and your speaker blasts you, coming out of the computer blasts at you, then you know you kind of made a mistake. So that's an easy fix. So, computer control. As I said, it's used to set frequency, mode, PTT, and it is a serial device. In fact, the radios back in the 20th century literally had a serial port in the back, and it would talk, and Windows would see that as a COM port. So what is, now today, there are no serial ports on your computer, but there are USB ports, which actually, USB stands for Universal Serial Bus. Now, there are devices that emulate old-fashioned RS-232C serial. So one end is the USB connector, the Type A connector, and then the other end is a 9-pin DE9, not DB9. DB means 25 pins, DE9. And these devices are specific to the brand, ICOM, Kenwood, and Yaesu, my favorite radio manufacturers. And they're generally the same across different models for the same manufacturer. And as I said, Windows sees an external serial or an internal serial interface the same. And that's just how it's a packaging issue. Now, a great way to get started is to go manual. If you can establish a connection and exchange email with a Winlink node, so as I mentioned, is the WB3KAS and W1AW. You can use them during the day. 40 meters is great. And mode is upper sideband for digital modes on all bands, including 40 meters and below. Now, if you hear some talking, just as an aside, and this happened to me today, I wanted to connect to W1AW, and I heard the upper sideband version of single sideband on 40 meters, and I bet there's a QSO going on there, and I switched to lower sideband, and right on the money. It was 7.100. That's what W1AW is, and I said, okay, this has frequency. So I moved off to WB3KAS, and that was free. So the dial frequency that you enter on your radio, that you dial in on your radio or enter it, is the center frequency, the Winlink center frequency, minus 1.5 kilohertz. Now, I have to tell you from experience, I can't do subtraction. I could barely do addition, but subtraction is, so the Winlink frequencies are typically reported as the center frequency inside the passband of your audio of the radio. So there's a good way to get started. Now, so ICOM. So I've played with quite a few radios, and all their radios use CIV. That stands for Communication Interface number 5. And it's a binary half duplex request response protocol, which is simple. And in fact, at the plug that you plug in, it's a 3 point, it looks like an audio plug, a 3.5 millimeter plug that's, or 1/8 inch. It's actually a mono plug, not a stereo plug. And you just, but the audio receive and transmit are tied together. That is, in this case, the data, not the audio, but the binary, the leads for transmit and receive are actually tied together because there's no conflict. It's half duplex. Now, they came out with a CT17 level converter that converts from RS-232, and that's a protocol that swings between plus 12 volts to minus 12 volts, or could be anything, or 18 volts plus or minus, to digital logic serial, and that means it swings either from 5 volts or 3.3 volts to 0. And with ICOM radios, you don't specify the model name, as with Yaesu and Kenwood. You specify their CIV address. So in Winlink, the radio type is ICOM radios or ICOM transceivers, and then you specify the CIV address, and that you look that up from the radio menu setting. Kenwood, interestingly enough, ASCII. What does ASCII stand for? American Standard Code for Information Interchange. It's readable text, and it's half duplex, similar request response protocol, but you can read it. And it's very well documented. And the standard is the Kenwood TS2000. They have the best documentation. And I actually played with that. I wrote an Arduino to pretend to be a TS2000, and it works. So, and back at the Kenwood radios, they still use the DE9 milk 9-pin connectors. Now, so you can buy from several sources a cable, a USB to DE9, and this is a generic cable. I bought cables just basically USB to serial 9-pin connectors, and it just works. And in fact, Flex Radio picked up the TS2000, that is the Kenwood control language, for their Flex Radio line. And they say in the manual, this radio emulates, it pretends to be a TS2000 as far as RIC control is concerned. So, and Yaesu, so I finally found it, what CAT stands for. So HAMS is colloquially, these colloquialisms. So, oh, CAT control, meaning just generic RIC control. It stands for Computer Aided Transceiver System. And again, it's similar to, not as sophisticated as the ICOM's binary half duplex request response protocol. And I've seen two styles for the larger radios. Typically the desktop, it uses the RS-232 DE9 connector, or small radios, such as the FT991A. It uses a 8-pin mini DIN, and that uses digital logic. So again, there's a CT62 level converter, and there are third-party markets that have these things. The original level converters from the manufacturers are very expensive. I guess they figured somebody wants a museum piece from the last century, sure, go ahead, go ahead, buy it, no problem. So I just want to point out one thing that ICOM gave this a little thought, that you can have, as far as I know, is 4 ICOM devices on a CIV network. And there's basically what that is, it's the box with 4, looks like audio connectors, and you connect a mono patch, you connect the appropriate patch cables to all your devices. I actually have an original ICOM. I picked it up along the way in my travels. So now let's talk about Winlink. So it provides global email on VHF and HF over ham radio. And again, this is a live link. And it tells you what all the channels are available. And it also supports direct station-to-station, peer-to-peer. And that's a great way to practice Winlink, is to work with a buddy across town. To me, HF is much more interesting than VHF from an MCOM standpoint, because if there's a blackout in this area and there's a power failure, unless the Winlink VHF gateway is blessed with long duration backup power, well, that will fail. Well, even if the Winlink gateway on VHF does answer, well, what about the internet? So, but, you know, I've learned from my MCOM friends that distressed areas, the radius of a distressed area is typically, for planning purposes, 100 miles. So the goal is to reach outside a 100-mile radius from where you live. And certainly W1AW fills that requirement. And so hopefully we use Winlink for emergency communication drills and not an actual event. More about drills later on. So this is where you can download it. You set up an account and you pay them, what is it, $25. You can turn off the reminder to register, and it's a one-time charge. And they give you a string of letters and numbers, and that's your registration key. So don't lose that. So this is, I'm going to show you what this looks like. So this is when you first open it up. Oh my goodness, 741 messages. I've been pretty busy, I guess. So you click on settings and Winlink setup, and then preferences. So this is what the setup looks like. The call sign. I haven't done this in about, well, over 10 years ago. Probably over 20 years ago when I first set this up. There is a way of getting a password. I think what's involved, you log in to their winlink.org, you log in, or you just simply start using it. I'm a little rusty on that, so apologies for that, but you can obtain a password. And you donate actually to the Amateur Radio, Amateur Safety Foundation, Inc. It's a nonprofit, and I'll give you a key. Anyway, put in your contact information, and your grid is very important because, oops, I didn't realize click changes the page. Grid location, because you're going to get an estimate how far you're connecting to. So if I take it on the road, I look up my grid square, and these days I just use an app on my cell phone to get my grid square, and I put that in. And of course, you got to remember to change it back to your home grid square when you get home, when you come home. Okay, so I like to add contacts to my contacts list for every message that I send out. So that's how you accumulate a contacts list, and so that's useful. And now So, and Al reminded me, he reviewed this document, and so did Jim. Thank you, both of you. Reviewed it before I posted it on the Mark website. And Al reminded me to tell people that in addition to the drop-down box where you scroll, where you select the right session, open session is a button. So when you click on it, it turns blue. So here's the blue button right here. Open session is a button to click on after selecting the session type. And people get stuck at this point. So what now? Well, nothing's happening. So thank you, Al, for that. I actually fell into that trap once. Fatigue will do that. And so I've opened up the session and I'm going to click on the settings menu. And I want to select VARA TNC setup. They call it a TNC, it's just legacy. It's a modem. Now, so how does Winlink talk to the TNC? Through a standard IP port. It happens to be local on the same machine, same computer as Winlink is running. But you know, I've actually tried this, running VARA HF and VARA VHF on a different computer where I was running Winlink. And yep, vanilla TCP/IP works great. But what I really want to point out is session bandwidth, 500 hertz. And here are the good reasons. At night or often during the day, depending where you are, it's busy. So you really want to be a good neighbor. Also, if you're using an narrow bandwidth, the so-called hidden transmitter problem, just because you don't hear a transmitter doesn't mean someone's transmitting. So they may be interfering with your signal. So 500 hertz versus 2300 hertz. So there's a fourth, the probability would be a fourth roughly of being stepped down. Anyway, so uncrowded bands such as 6 meters. That's a great band to learn, to experiment and to learn locally around here. It's very quiet. When you don't have DX coming in, and DX is typically in specific portions of the band. So 50 to 54 megahertz, it's wide open. So you can go at 2300 hertz. Now, I learned today that 2750 hertz is not permitted on HF on the Part 97 rules. I saw that, I was wondering what that is, but now I know. Don't do it. So, setting up the 706 Mark II G, and specifically I wanted to play and learn with older radios to make the point. They're very capable. So today's recording for my VARA HF session was done with a TS2000. Again, also with a USB SignaLink. So the mode is upper sideband. I set the power to 100 watts. That's the setting on the radio, but I'm not going to use 100 watts output. And you adjust the squelch control to reduce the background noise. But I have to say, on more than once I would forget to do that, but VARA modem is very capable. It knows what to do with random noise. You really want noise to be as random as possible because it averages out to zero. Not zero, but it averages out to something that the software knows what to do with. It's those pops and those clicks, and especially periodic pops and clicks that has more of a hard time. So SignaLink, USB, that's the mid position, 12 o'clock. And delay is minimum plus a smidgen so that it doesn't clatter when you're doing your CWID. The VARA packets are quite long. that's for transmission. For acknowledgement, they're pretty short. So you may have to adjust the delays to keep the clatter to a minimum. Anyway, so this is the header modules for this particular radio. And let me tell you, I made my own cables, and inside on the header module, you can actually put in little jumper wires. In fact, Tigertronics supplies that. Let me tell you, it's really worth getting the headers. It's for $10. Now, frequency control cable. I like Valley Enterprises because it's FTDI, true blue, vanilla, FTDI chipset, and that's well understood. And it works. There's also RT systems, but apparently they're a big enough manufacturer that they can actually burn into the chips that says that Windows sees it as RT systems. So what chip is it? I don't know, but it works. They've been around forever, so it's a little bit more expensive, but it's a good product. So typically I buy one of each to test them out. Okay, so we're going to open up a VARA session. So you click on the open session button. There we go. And what? What's going on? Am I signed out? No. Hello? Can somebody talk to me?
Yep, you're still there.
Wow. I thought I put the other laptop to sleep. Okay. I got a pop-up here and that kind of threw me. Okay. Anyway, thank you, Paul. Okay, so we're going to click on radio setup. And this is pretty much the only window that is radio specific. And in this case, it happens to be ICOM amateur radios, is pretty generic, but you got to put in the ICOM address. So if I would switch from an IC 7300 to a 706, it wouldn't work. I go, oh yeah, what's the? So after a while, you get to memorize the ICOM addresses, and you look up the baud rate for that. And for the 706, I set it for 19.2. Oh, I found out it was 19.2 kilobits per second. And in this case, PTT, well, you're using, well, SignaLink. So you just indicate that as external. Okay, now, it's a good idea periodically to do channel select. Now, of course, if you don't have internet, you could do this over the radio, but you can do internet, you can do update via internet. It takes minutes. So what I did is I've downloaded this, and that is, I refreshed it and downloaded it, and then I sorted it for path reliability. So not surprising, 39 miles away from Rockville is Jim's station over there. Stations all over the world. It's quite remarkable. I've used 20-meter radio, the email gateways, Winlink gateways. That works. But from my experience, 40 meters during the day for local within 400-mile. I'm not going to say it's 100%, but it's quite reliable, quite dependable. And so click on the menu settings and select the sound card. And you really want to, VARA often selects the wrong one, even though you set the default to be the computer speaker and microphone. So you have to always check for that. Now, this screenshot, well, before I talk about the screenshot, that is, so you set the audio, I'm going to give you a rule of thumb. For older radios, and you won't go wrong with all radios, that is current radios. I mean, it's amazing, the radios that come out today. It's just, I'm amazed. And for a reasonable price, relatively speaking, for what they give you. So here's a rule of thumb. Set the audio drive level to little or no ALC. You won't go wrong. So originally with the radios, and this is my experience with the FT857D and the ICOM 706, is that ALC, if it starts to flicker, means you're starting compression, which means when you do compression on transmit, you are distorting. You don't want to distort. You really want to keep those bits, that is the audio carrying those bits, as faithful, as linear as possible. Now, the truth is, study the manual. See what the recommendation in the manual for your radio model is for digital modes, and that will tell you. For my KX2, which is a Elecraft, they say 4 to 5 bars, and then compression starts to happen. Okay, that's in the manual. And Al sent me an email saying the same thing with his KX K3 or K4, similar specification. But if you're under driving your radio, that's fine. It's okay. Now, this screenshot, this is from the VARA setup. It shows that for the IC 7300, it will tolerate a third ALC. Okay, that's fine. This is off the record. I'm going to tell you about my experience with 2 different IC 7300s. I drive these at 100% power, RF out. With the older radios, when you have no ALC, it tends to reduce the power to like 50% to 70%, which is really a good idea, because ham radios in those days were really amateur service. If you run in full power, 100% out for long periods of time, you risk burning it out. That is, you risk damaging it. And so, a word from the wise. Now, because the 7300 has a temperature gauge right on the display, I was curious to see how the temperature would rise on the power amplifier. And for long key down, long transmissions, like 10-minute transmissions, long files, it barely budged 1 or 2 bars. Amazing. So thank you, ICOM, for being generous with your power amplifier chips. And they have a nice big fan in the back of the radio that keeps it nice and cool. Now, it's not recommended practice, especially on a hot summer day, because the initial temperature of the radio is going to be the ambient temperature. So keep that in mind. Anyway, so simple rule of thumb. It's okay to underdrive it. In fact, the TS2000 was set for 100% power, but I set the power drive to about 10 to 15 watts. That is, it would flicker, the ALC would flicker, not the ALC, not the PO, the power output would flicker between 10 and 15 watts. Great. You don't need much power. I'm amazed at how little power I can communicate with. I've done 5 watts, I've done 3 watts, I've actually done 200 milliwatts. I can connect to W1AW on 10 watts from here, Rockville, amazing. Now, so what's the magic of local communication? So if you take a horizontal antenna, which is a quarter wavelength or less above the ground, basically you're taking your radio, the radiation goes straight up, it bounces straight up. So basically you're using the ionosphere as a mirror. So it gives you a range around 300 to 400 miles. And my experience, 440 meters during the days, I've yet to not be able to connect to W1IW during the day. Now, I haven't taken measurements. I mean, I haven't done it every day. Scientifically take regular measurements periodically. I haven't done that. But anecdotally, that's my experience. And same thing, 80 meters. So I would get an email from Jim, and it says, why don't you connect to my radio? And this is an email like at 10 o'clock at night. I'm going to leave it on all night. So of course I'm a morning person. So I get up at 5 and I try it and it works. 80 meters during the day often doesn't work. So there is a real-time NVIS frequency that will tell you what it is, assuming that you have the internet. But these are general rules of thumb that I found that works. Remember, you have to be able to communicate with this. You have your radio, you have power to power your computer and your radio, and that's it. You don't have any internet. I mean, that's the game plan. So I like to test things in the field. I love going to the field, meaning to a park, because I live here in a radio noisy environment, S7, S9. But I'm amazed how well the digital modes, how well VARA does with all that noise. But if I want to have a good experience, especially with FT8 or PSK, I go to the park. And Black Hill Regional Park comes to mind. There's an area there, a dog park with nice parking, good parking and trees, and no picnic tables. So there's a fenced-in areas for the dogs, and so that's a good spot to set up. Now, a convenient antenna to set up is an inverted V. It's a modified horizontal dipole, and you just basically need one pole and 2 anchor points and some rope. And there are calculators that you plug in the numbers. So I like to use more than one source just to make sure that the numbers agree. If somebody is off, somebody made a calculation mistake. What's interesting about the inverted V, yes, you have less gain than a dipole, but because the 2 legs slope down, you actually have some radiation coming off the ends, as opposed to a true null at a horizontal dipole. So that's actually a plus if you want to be more omnidirectional than a dipole. So this is something that I built to deploy rapidly. And I have 32 feet. This is for 40 meters, a 16 gauge antenna wire, and 8 feet of rope at each end. And the slope is 45 degrees. 45 degrees is a nice number because you take the length of the wire and you multiply by 0.7, which is the square root of 2. And that gives you the idea of the height of the pole that's needed. And it turns out to be about 25 feet, less than 30 feet for NVIS, for 40 meters. And also the distance from the base of the pole, the mast, to your anchor point. So this is what I use, 34-foot mast, but I use only 28 feet. Flagpole tire mount. Now, I have pictures of this. I use a coax cable. I found a balun with a screw attachment, very handy, a diamond. And you don't want to pound stakes into concrete, asphalt, park grounds, especially when the ground's very hard. So I have weights, and I measured with a graphical antenna analyzer. I get 1.7 to 1 at 7.1 megahertz, and it can be deployed by one person. So this is what it looks like, and a tire mount. It's called a flagpole tire mount, and it happens to fit. It's a little bit wider than the MFJ mast, which is fine. So I shimmed it with gaffer's tape, and it slips right in. So how does one person know where to park their vehicle? What you do is you take the driver's side mirror and you just aim it down, and you just move your car 10 centimeters, and you're good. Now, this is a telescopic mast, and quickly learned you really need to secure the coax to each section of the mast, because one section on top can't support the weight of the antenna and the cable. I did that. I erected it, and it immediately collapsed. I said, I was wrong. Do over, but luckily I didn't break it. So now the key to this mast is grippy gloves. And the reason why it's green is because I used it to tighten, untighten the mast quite a few times. Without that, it's very difficult to, not so much to tighten, but to untighten. But you could do a much better job with these gloves. And the ties, one of my favorite attachment devices is shoelaces. They're reusable. And for a temporary deployment or a day in the park for a couple of hours, it's just fine. Now, I found Diamond has a nice balun. It's rated for a kilowatt. And notice the screw terminals. And I like to make everything reusable. So this is a Teflon insulator. And the wires, when it's threaded through twice, and it doesn't slip. So this is a shoelace that holds it to the balun. Oops. I clicked. I should point, but not click. Click means go next. Sorry about that. And that is tied to the top of the mast. They have an eyelet. The very last segment, it's too thin to be useful, but there's an eyelet there. So I attach to it, and then I leave it be, and then I pull up. Rather, I pull up the second segment from when you assemble it. I pull up the first segment and then the second segment, and just before before I push it up, I'll just detach. I'll lower the first segment again, because it's thinner than a pencil, so it doesn't give you any vertical strength. Okay, and now one of the things I learned is that it's the electrical length of the radiation element, that is the wire. So I needed to make it adjustable, and I'm glad I did, because I actually measured it. I finished assembling it in the park because I needed a long 66 feet worth, or a little bit longer, to lay out the wires at both ends, and so I can measure it with the 100-foot tape measure. But I know from experience is make everything adjustable. And this is a much easier way than having to trim the antenna, physically trim the antenna. You just fold it back, tie it, and wrap it around itself. So electrically, it's not there. And you secure it with zip ties. This is my gravity anchor, $1 a pound once upon a time. So I bought 6 of those, very handy. Now, this is the antenna all stowed on a bobbin. So where did I get this nice bobbin? The answer is, I made it. Carry out, typically from Asian restaurants, carry out. You take 2 of these containers. These are the shallow containers. Use hot glue to quickly. You put some hot glue around the edge, not the edge, but inside the edge, and you put it together. And you'll have about 5 seconds to get it aligned, so it's relatively uniform. And then you take gaffer's type. Gaffer's type is cloth tape with sticky stuff. It's used in production. There's video, movie production, audio production. So you can put cables down and temporarily, and then remove it and not leave a residue. So great stuff, but not cheap. And that becomes my bobbin. So if you do a lot of carryout, you have an endless supply of bobbins. And this is the setup. And so this is from Black Hill Regional Park. I'm going to zoom. Oops. How do I do this? No. There. Now, how can I zoom in? Can I zoom in on this? No. Anyway, if you look closely, you see that the TX light is lit up red, and I'm running 5 watts, both to WB3KS and W1AW, because if you build an antenna, you have to test it. So this is the 7300, and this is the temperature gauge I was telling you about right there. And so that's what that looks like. And so I spoke for about an hour. We have time for a video. I didn't want to tempt the demo demons by doing a live demo. So I'm going to play the video, and it's 6 minutes long. And let me maximize that. How do I do that? F11. And then press play. The nice thing about video is I can pause it instead of doing a voiceover, because it's going to get noisy soon. So this is a TS2000 and a SignaLink, and I have a camera plugged into my laptop computer, and the mic, the Zoom mic, was actually the SignaLink. So that's not really a hack. I realize you can use it any mic as a Zoom mic. It doesn't have to be a microphone. So this is what this looks like. So I'm going to start. There we go. I don't know where that square comes from. It's an anomaly with something. It doesn't interfere with the demo, luckily. So when you open up a session, it also opens up the modem for you. And luckily that square went away. And if you look at the SignaLink, when it turns red, the radio mutes, of course. And there we go. So connected to the WB3KS, 29 miles away. And what you see here, that X pattern shows the goodness of the signal. So what's happening here, it's sending 2 bits at a time. In the olden days, they would talk about baud rate. And what's a baud? A baud is a symbol per second. So in this case, a symbol is the 4 combinations of 2 bits at a time, hence the 4 quadrants. So the closer you are to the X, the better it is. And notice the signal to noise ratio. It's pretty good. It's practically off the scale. So that's a win. So let me pause this to make a point. If you think 500 hertz is not enough bandwidth, you'll see that it's actually not so much of an issue. Notice the speed I'm going at. I'm going over twice the bandwidth in terms of bits per second, which is in this case 1200 over 1200 bits per second. Amazing, very clever. Clever coding, clever modulation. Anyway, let's continue. Oh, one other thing. I've actually experienced a better speed running at 500 hertz than 2300 hertz. And why is that? It's because the software is only processing 500 hertz of bandwidth and ignoring the rest, everything outside, just ignoring it, not processing it. because it's not about bandwidth, it's about signal to noise ratio. And you really learn firsthand in your gut, signal to noise is everything. Anyway. So you notice the speed varies. It's constantly testing the goodness of the data, or rather the audio coming in at the other end, and it sends back in the acknowledgement packet how it should transmit. Now, we had a drop packet because in addition to the data, they put in some pretty fancy forward error correction, redundant data. And if the data gets corrupted and it cannot be recovered, reconstructed, it can tolerate a small number of errors. But if it cannot recover, it just sends back a knack. And you'll see data here is green. You'll see it come up as red. This is just amazing. I just want to say, if you're using the unlicensed version of Vara, you'll get 88, I think it's 88 bits per second. Now, for short emails without attachments is totally adequate. And likewise, if you're receiving a large file, the acknowledgement packets are small, so 88 bits per second is absolutely fine. But I don't think $69 is that onerous if you're reasonably, if you want to continue playing with this stuff and using it. See, there we have a drop packet. It turned out red. See, there's a gap. Almost done. Now I'm receiving data. 1,500 bits per second. That was 3 times the bandwidth. Amazing. You'll notice these are powers of 2. It's like 2, 4, 8, 16. That's the number of bits in a symbol that you can put in. The audio sounds, coming out of the radio sounds much better than that. Zoom wants to do noise suppression. And even if you set it at the lowest setting, it still distorts it. So, but it gives you an idea what it sounds like, a rough idea. But you have to, if you experience it firsthand, it's a much cleaner, nicer sound. The other thing which I learned is noise has a sound to it. And you can look at the characteristics of the noise on the waterfall. You just tune between stations. I've learned there's something called good noise, good clean noise. Because the average of noise is 0 or 1 or some, it basically it averages out. Anyway, so. I'm going to speed this up a minute. Oh. Oh, there we go. I speeded it up to gain myself. But there's a neighboring station. Oh, I didn't notice that, but you saw briefly that. That's what the. Let me rewind. That was the message that I sent. That's my test file. That's 12 kilobytes. So I'm done with that. So let me finish up the last couple of pages of this video, of this presentation. And how do I maximize? So I go like that. There we go. Okay, so my backup to a video is screenshots. Okay. So where do we go from here? So it's more, you need to practice this. I've been practicing this for a couple of years, on and off, and you learn by doing. But there are periodic practice exercises. Winlink Wednesday, another Winlink. So every Wednesday they have an exercise, and you connect the stations. They give you an activity. Winlink Wednesday, Puerto Rico. There's another group, MCOM training. Of course, the Montgomery County Auxiliary Communication Service has drills, and so does PG County. So join those organizations and get on the email reflector. So last but not least, the summary. So the presentation is to get you started on HF. I apologize for running on more than an hour, but it's a lot of stuff. And Windows settings are essentially the same for all devices, whether they're built into your computer or they're a little box on top of your computer, as far as Windows is concerned. And always check your settings. Whether it's, this is also true about Windows settings for radio control, whether it's built in or external. Easy way to set up is you get a SignaLink with the box PTT and manually set the radio, and you get that to work, and then get your rig control to work, and then you just practice, do drills, work with buddies, connect to stations. My favorite station is W2LNX. I connect to myself. Basically, I send email to myself at testing. So thank you, these nice folks. I am privileged to be part of a learning community known as Amateur Radio, and I learn from each other. So everything which I've told you is what I've learned from these good folks and by doing.
Well, thanks, David. What a terrific presentation. I can tell you did a lot of work on it, a lot of thought. And so a lot of good guidance for people to use if they're getting started. Do we have any questions for David?
Okay, NG3D here. If I were just to turn on my receiver, at what frequency would I hear the raw signals just to find out what they sound like.
Okay, I will direct you to, I'm going to go into screen share mode and I will answer your question. Let's see. Oh, by the way, as I said before, this material is on the Montgomery Amateur Radio Club. You click on that, then you click on training, you click on getting started with Winlink HF, and there it is. Come on. Well, it's coming up. It's lucky. Okay, winlink.org. So you go to tools, and then you go to RMS list, and you go to mode, which is VARA. Now, VARA first came out, and then VARA FM came out. So everybody knows when you say VARA, they mean VARA HF. I make it a point to say VARA HF all the time and VARA FM all the time, so there's no confusion. So if you want to listen into Jim's station, let me see, can I search for 3KAS? Oh, there he is. He's in Brandywine, and you tune in. This is the center frequency of, see, center frequency? Yeah. I'm going to go to the top. How do you go to the top? Home? Come on. Wow. Oh, there it is. My scroll bar. See, this is the center frequency. Remember that Winlink is frequencies are reported by the center frequency of the passband. Let me go down to his. So that's his frequency. And if you want to listen in, set your radio to upper sideband and subtract 1.5 kilohertz from this. So let me see if I can do the arithmetic. So what would that be? 7088.5 kilohertz? Did I get that right? Yes, I got it right. I think I got it right. Anyway, and just tune in and you can listen in. And another strong station is W1AW. So how do you spell W1AW? 1AW. So during the day.
So David, Jim had a question.
Yeah, Jim, go ahead. Thank you, Jim.
Okay, fine. Very good. Those who are going to be those who are considering listening to the frequencies, I'm scanning 3 bands, so it's 80, 40, and 30, and so it listens for a few seconds. Let's go to the next band. Go to the next band. So there's a 3-second delay between bands, which averages out to be 7 to 10 seconds before it goes back to the beginning again. So if you're going to listen on 80 and you don't hear anything, I might be on another. I might be scanning another frequency. It may be. I'm sorry. It may be locked onto another band transferring data. Doesn't mean that the frequency I use cannot be used by somebody else. Okay, you gave him the frequency of the center frequency plus the 1.5 or minus, I forget where it goes. If it's not there, it doesn't mean that I'm off the air. I might be on 30 and 40. And I'm going to cycle back to 80 again. I've had people say, "Hey, I've tried to check with you a couple of nights. I don't hear anything." Well, that's because I'm not there. The station is passing traffic on 40 and or 30. When it's all done, it cycles back to 80 meters and so on. Clear as mud, right?
The thing to realize, these gateways are passive. They don't beacon, they don't do anything. They just simply wait for an incoming request, and then it will respond. Quite common, I would connect to a station and then I would time out. And then I immediately would connect again right away because I was at the end of the cycle or the beginning of the cycle. Well, you know what I mean. So
yeah, if you can hit it again within 3 seconds, it'll lock on before it goes to the next band. There are some bands that have 5, 6, or the HF band frequencies. And I don't know how they do that, and I don't know why it makes that much sense, but I have 40, 80, 40, and 30 because those are the 3 main bands for MCOM. Doesn't mean you can't do it the other way around, but those are the three NVIS propagation kind of bands.
Right. I've been experimenting with 6 meters. The nice thing about 6 meters, it's the newer radios include 6 meters as an HF band. So you have 6 meters thrown in, and you can run it on sideband and some of them FM.